All right, coming at you from Casa de Hadin, and we are going to do 13.0, which I don't even know how that's a thing, but it is, and we're going to revisit SOH, which is something that you probably have fond memories of from geometry. So let's get this party started. First of all, SOH only works with right triangles. So that makes it trigonometry, which is right triangle math. And some of the things you want to remember from geometry about triangles in general is the sum theorem simply tells you that the angles total 180. So if you know two of them, you can find the third one because they have to add up to 180 degrees. And maybe we'll use my fuzzy haired pen because that pencil didn't turn out very dark. Pythagorean theorem, hopefully you know a squared plus b squared equals c squared, keeping in mind that this has to be the hypotenuse. And as a result, that also has to be the longest. Okay, so just because we're e-learning does not mean my handwriting got any better, so sorry. SOH is just a mnemonic device to help us remember that the sine of an angle, and by the way, this is theta, and it's a variable that we usually use for angles. We've seen it before in class, but that doesn't mean you necessarily remember it. So now you will. So the sine of theta compares what we call the opposite to the hypotenuse. And so it'll become really important that you label your triangle. Opposite means that if this is the angle I'm looking at, opposite is going to be straight across from that. So in this case, that would be the opposite side. Then the cosine of theta compares the adjacent side to the hypotenuse. And the adjacent side is exactly that. It's adjacent to, it's next to or touching the angle. So this would be my adjacent side. The hypotenuse is always that long side. It's always across from the 90. And so our last trig relationship for today is the tangent of theta. And that's going to be the opposite side. It's just the comparison of the two sides we have not yet compared. The opposite side over the adjacent. So that is where SOH CAH TOA comes from. You have that the sine compares opposite over hypotenuse, cosine compares adjacent over hypotenuse, and tangent compares opposite over adjacent. So it's just a way to help you remember what's comparing what sides and help you kind of just keep all of that information straight. So what are we using it to do today? Today we're going to be using it, excuse me, to find sides. And so when you are trying to find the sides, you're basically going to go through a few steps. One, you would normally draw a triangle, but these are already drawn. Once you have the triangle, I would highly recommend that you label the sides. And you can just label them opposite, adjacent, hypotenuse using one letter. It'll help you, especially in the future as we add more things to our list of things to do. Once you have them labeled, then you use the SOH CAH TOA. So if you had the opposite and the hypotenuse involved, you would use sine. If you had the adjacent and hypotenuse involved, you'd choose cosine. And if you have the opposite and adjacent involved, you would choose the tangent. So you're going to choose one of those based on the two sides that are involved in your problem. And then the third thing you're going to do is you're going to just set that up using these relationships up here and solve. See, it's that easy. Let's do a couple. I'm going to get out my trusty, really old calculator with a blob on it since you guys know someone stole my calculator and never brought it back. And then when they did, they didn't bring me a charger and it's dead. So this is the one we use. So, okay, in this problem, here's the angle that they gave me. So if I shoot straight across from that, that makes this the opposite side. Here's my diagonal that is across from the 90, so that's my hypotenuse. And the adjacent must be the other side. But in this problem, they don't give me the adjacent, they don't ask about the adjacent. So the two things involved are my opposite and hypotenuse. Because of that, when I go back to SOHCAH, opposite and hypotenuse would be telling me to use sine. So this is going to be a sine setup. So I put the sine of my angle, and if you want to put that over 1, you certainly can. It just helps you recognize it as cross multiplying. And then I would put equals exactly what it equals, opposite over hypotenuse, which in my picture is going to be the x over the 42. And then if you think of this as cross multiplying, you're going to get that 1x, which is just x, is going to equal the product of this other cross, which is going to be 42 times the sine of 55 degrees. Make sure that your calculator is in degree mode. So when I turn my calculator on, there's a little bit of a glare, sorry. If you go to mode, you can see that the third thing down is radian degree, and you want to be in degree mode. So in this case, I would take 42 times the sine of 55 degrees, and it will calculate that for me, and it says to round to the nearest tenth, and so I would go ahead and say that x is going to be about 34.4. Which is reasonable because it's in the same ballpark as 42, but it's also less than 42, which is important to remember because the hypotenuse is the longest side. If I had to find that third side, I could use SOHCAH TOA, or I could go back to remembering that I have Pythagorean theorem and could find the third side that way. All right, so let's pick up the pace because we're smart. So in this one, I've got my angle, straight across is opposite. This would be the hypotenuse, but that's not involved in my problem. They're not asking me about that, and I don't know that number. So this is going to be the adjacent side. So because I have opposite and adjacent involved, I'm going to pick tangent. So the tangent of my angle, and again, if you would like to have it over 1, go for it, equals the opposite, which in this case is 13, over the adjacent, which in this case is my x. So here I'd be multiplying this way, and I'd end up with x times the tangent of 63 equals 13 times 1. So to actually solve for x, I end up doing division in this problem instead of the multiplication I did in the previous problem. So again, I just keep my calculator in degree mode, 13 divided by the tangent of 63, and that side would be about 6.6. And again, I'm rounding to the nearest tenth because that's what the directions said. And it looks about right. I could do a squared plus b squared to get c squared now if I had to, but I don't have to. So let's move on. Here in this fun problem, they made the triangle kind of in a funny orientation. So I'm going to label it again. This is my angle. Nothing is labeled across from it. If I go straight across, there's nothing on the opposite side. So that means that this must be my adjacent side, and then across from the 90 is going to be my hypotenuse. So my pen just died. Excellent. Let's try this one. No, that's not going to work either. This so far teaching from home is going super slick. Okay. I can't decide if it's going to work or not. Adjacent and hypotenuse means I'm going to use cosine of my angle. And if you want to put it over 1, go for it. If you want to get away from that, you certainly can. And then that's going to equal my adjacent side over my hypotenuse. And so like we had here, with the variable on the bottom, I end up just swapping these out really, so that I end up dividing. So this x would come up to this side, but the cosine 57 would come down, and x would equal 40 divided by whatever the cosine of 57 is. So if I do 40 divided by the cosine of 57, I get 73.4. And again, looking at my picture, that is the hypotenuse, so it should be the longest side, so it seems like a reasonable answer. All right, this is the last one of exactly this type. So let's hustle through this. I've got my angle. This is the opposite side, but there's nothing there, so it's not a part of my setup. this must be the adjacent side, and then this is the hypotenuse because it's across from the 90. So again, with adjacent and hypotenuse, looking at my SOH-CAH, those two mean I'm going to be using cosine. So the cosine of my angle equals the adjacent, which is my x, over the hypotenuse, which is 59. So in this problem, to solve for x, I would be multiplying that 59 up to the other side. And then I would do math, because we're in math class. So 59 times the cosine of 36 gives me a length of 47.7. Okay, so now you know everything in the whole entire world about that. And we are going to start doing what we do in math, which is a little bit of an application / word problem. You lean a 16-foot ladder against the wall. If the ladder makes an angle of 70 degrees with the ground, how high does the ladder reach? Now, they were kind enough to provide us with this real-life photo over here, but when you have a word problem, keep in mind that we're doing trig, and trig only works for right triangles. So every single picture has to result in a right triangle for now. Foreshadowing. So in this case, the ladder is going to be this thing, and it's a 16-foot ladder, so that's why that 16 is going to be on that length. It makes a 70-degree angle with the ground. When you are measuring up from the ground, keep in mind that the term for that is going to be angle of elevation. And so they'll use that term, and you need to know that that means, hey, you're measuring from the ground on up. And in this case, that is going to be a 70-degree angle. Now, if I don't draw it exactly 70 degrees, nobody cares. I'm just setting my triangle up so I can see the parts. It asks how high does the ladder reach. So that's supposed to be my x, which is here. How high does that ladder reach? And so now I have my triangle. This is across from the angle, so that's going to be opposite. This is across from the 90, so that's going to be hypotenuse. So looking back at my SOH-CAH, if I have a problem with opposite and hypotenuse in there, I'm going to look back and do the sine. So I would set up with the sine of 70 degrees equals the opposite, which is x, over the hypotenuse. The number's on the bottom, so that's an easy solve. I'd bring that up, and x will be 16 times the sine of 70 degrees. And you guys probably already know what that is, but I have to do it on my calculator because you guys are smarter than me. So that means it reaches up about 15.0, it says nearest tenth, so 15.0 feet, because it's a word problem, and I like to get full credit by having the label there. Okay, so in terms of kind of a topic, I suppose you could call that the end. So if you want to quit now, you certainly can. What we did was using SOH-CAH to find sides. Going forward, we're going to be doing inverse in order to find angles. And so I'll make a separate video of that so that you can watch it at a different time. Peace out, guys.